Hello and welcome back to Aerospace and Mechanical Lab 2. Today we are going to talk about the next part of the numerical labs, which is the static structural analysis. So you have already run a successful fluid flow test. At this point you have already built a geometry, you have created a mesh. You want to use the pressure data on the traffic light beam off of the fluent analysis and then send it to the solid module, a static structural analysis module, to do the rest of the analysis for you. Okay, so the first thing you want to do is we want to recreate a geometry, because right now in our original geometry, if you double click on the geometry, you're going to see our focus was on what happens around the traffic light. Essentially, the focus on the air passing over. That's why we had this enclosure, right? But we don't really need the enclosure. We don't need to mesh the enclosure. We want to focus on what is happening inside or on the traffic light itself. We want to analyze the deformation. We want to analyze the stresses and the strains, and so on and so on. Okay, so yes, I'm just going to add another geometry module. It's right here. Okay, I'm going to drop it right here. Then right click on the geometry, and we want to do a design modeler geometry. We can also use a space claim. If you want to use a space claim, you are welcome to, but I'm going to use the design modeler geometry. For this design modeler geometry, we have to just recreate whatever we had before. We had a cylinder. We went to create primitive types and cylinder, and our cylinder had a radius of 30 centimeters, and then it was 8 meters tall. We can hit generate. That is our first cylinder. Then we have to create another one. I have to create another one. This one was originated as 7.5 meters in the Z direction, and then was 8 meters in the Y direction, with the exact same height, I guess, length. So this is our geometry. Geometry is made. We have one part, one body. Doesn't really matter if we add frozen or add material here. Specifically, we want to essentially adjust the traffic light. This is the base of our traffic light, and the rest of it is going to be left free. So we have to export or import. The export from Fluent and import it to the static structure module, the pressure data we have on this traffic light, essentially. Let me close this and go to the modules again. So a lot of these do a structural analysis for us. A lot of these modules, these are original ANSYS modules that existed in the original ANSYS software. The one that we're interested in is deformation or a static structural analysis. So I'm going to drag and drop it on the geometry specifically. So geometry is imported to the static structural module. We can also look at the engineering data part that essentially gives us the material we are using. I'm not going to change the material at all, but if you are interested in changing the material and using your own material, you are welcome to do so. You can use your own material. Okay. Go back to the project here. And then the next part is to import the solution. So I'm going to drag and drop the solutions here to the setup. See? Drag and drop to the setup. And this is where the solution is transferred. Next part is meshing. So meshing can be done within the static structural module. This is the original meshing software that was used in ANSYS, so it is very well connected to the original model they have, which is the static structural model. Maybe just take a little bit of time for it to open. Yeah. Have to load our geometry. Okay. So we have our traffic lights. Just want to make sure that everything needs to be exactly the same as before. So the size, the direction, the axis of the traffic light needs to be exactly the same as before. Here you can see the geometry import on the left hand side. You can see the geometry itself. You can change the material. We are using a structural steel. You can use anything else if you want to. You can add a new coordinate system, and you can create a mesh. This mesh gives you all of the options we had before. We can change the methods, we can change the sizing, we can change everything we want to change. But this is a simpler simulation, so we are just going to use the default values they have, the default meshing system they have. I'm just going to make sure that the sizing is correct. So the default, it says default size. We can change this default size to a smaller size. I'm going to change it to 25 centimeters, or let's actually do 10 centimeters. And then it is going to create the mesh, take the data from the previous fluid mesh and interpolate that mesh's data to our current mesh. So your mesh doesn't have to be exactly the same as, at least the surface mesh doesn't have to be exactly the same as the CFD mesh. Okay, then we can right click and update to create the mesh. Okay, so this is our mesh. As you can see, this is not a very good mesh, so we are just going to I guess make the default size smaller. Let's actually add a module here. It's going to be easier for us to control. So for the method, I'm going to use this. I'm just going to ask this to use a tetrahedrons method, and I'm going to add sizing. And I'm going to do a sizing for all of this, not just one surface. I want the element size to be, let's do 10 centimeters now, and hit update. This is a much better mesh. As you can see, we have some issues here. If you were running an actual project for a traffic light design company, you should definitely make your mesh finer and smaller to give you better results. But this is fine for the purposes of this lab project. So we have the mesh ready, we have everything, we have the geometry ready, everything is ready. Then we need to define boundaries and run the static structural modules. Okay, we can come to this analysis settings. We can change the number of steps, and we can change the step end time. We don't really need to change any of these here, but it is a very simple deformation analysis. Of course, if you change the number of steps to more than one, you're going to get a better result eventually, but again, we are just going to keep it simple for the purposes of this lab. The next part is to deal with the imported data. Okay. The data, all of the CFD data is imported here. We have to create a boundary condition. Essentially, we have to assign the surface, this surface, to our imported load. So we want to insert, again, right-click on the imported load to insert an imported boundary condition. We want to import pressure. Okay. So imported pressure, we just have to select the geometry. I'm going to select all of these surfaces here. Let's actually see, pressure for all of these surfaces is imported, but I don't want to import the pressure for all of these surfaces. I want to only import it, I guess, for all surfaces except one, except this one. We want to use this as a fixed surface. So we have to change the selection tool from the body selection to face selection and select all of the appropriate faces. Because this one is not selected, the last one, and then we come here, hit apply. All of the surfaces are selected now. Actually, this we are looking at for this surface. This is not selected, which is our intention. We didn't want to import pressure for this. We can go back to the static structure, right click on it, hit insert, and then it gives you a ton of different options. We are looking for this fixed support options. We want to click this surface to be our fixed support. So the system is ready now. Sorry. Yeah, the system is ready now. This is our fixed support. The rest of this we have imported load. There are a couple of things you need to check in your imported pressure. You need to make sure that everything is correct. First of all, the CFD surface of interest is defaulted to inlet. This is not our surface of interest. The surface of interest that was for us was wall solid. Wall traffic light, I'm sorry. Wall traffic light. Okay. This is the data we want to interpolate. The rest of this, we can change this to CFD focused, or we can change this to manual and change the mechanical mapping to CFD mapping, but we are going to leave these as is. And eventually in the solutions, you can report the deformation. I'm going to report the total deformation. You have to keep in mind that deformation here is a scale, so it is going to be a little amplified, the deformation. And we want to, we can report the equivalent or for Mises strain and for Mises stress. We can also report the energy in this beam, but we are going to keep this to deformation, stress, and strain. And then we are ready to solve the problem. Just hit solve. It will start the solution for you. Okay, we have the results. For a stress, it tells us the maximum stress is happening here. For a strain, it tells us the maximum strain is happening here at the base, again, and the minimum strain is happening here. These are all things that we expected. And deformation, we can actually run a simulation for deformation. This is not a real-time advancement of the deformation. It's just a real-time advancement of how the solution has progressed, but this will give us a good understanding of how the deformation works. So this is how the deformation looks. You're going to experience the maximum deformation at the edge of the traffic light, the free support of the traffic light. Again, this is something we expected. And then the minimum deformation is going to happen close to the base of the support. So this is the analysis you need to do for your lab report, the CFD part, the meshing part, and the static structural part. And then you have to submit this. You have to write a full lab report for the 3 different velocities based on the conditions that you are told in the report, in the lab instructions for this vehicle specifically. And you have to write your lab report based on those results and just submit it to Blackboard. This lab report is worth 15 points. You have to keep that in mind. That is it for today. Thank you for joining us. Enjoy the rest of your day.